Percent yield. So we've been talking about stoichiometry and how to figure out how much product is being made. Well, things don't always go perfectly. If you set out to make a dozen pancakes, sometimes you don't get a dozen, right? Because you misjudged the size, or one fell on the floor, or you got distracted by Candy Crush and one burned, right? And so the actual yield that you get is not always what you theoretically could get. So we have a couple different terms here. We've got the theoretical yield and the actual yield. The theoretical yield is what would be calculated using stoichiometry. Everything works out perfectly. This is the maximum amount that you could get from this reaction. It's theoretical. It's calculated. The actual yield is the amount that you actually get. Okay, so the name is descriptive here, how much you actually get. There are lots of different reasons that the actual yield can be different. Occasionally, the actual yield will be higher than the theoretical yield. This does not mean that you created matter. It means that something is wrong. One way that this can happen is if you're collecting a solid out of a solution and you don't let it dry completely. If it's wet, then that water will increase the mass of the thing that you're weighing, and it will look like you have more product than you actually do. And so you could end up with an actual yield that's higher than a theoretical yield. Anytime the actual yield is higher than the theoretical yield, there's a problem of some kind. When I was taking a quantitative analysis lab, we did an experiment where we were heating our sample in a crucible to burn off the filter paper. And we'd been working on this for almost, I think, over 3 hours. I think it was the second lab period. So going on 6 hours of working on this experiment. And the grade depended on how good your answer was. And one of my classmates, he was ashing, and a fly flew across the crucible. The heat from it killed it. It fell into the crucible and burned up. That's going to cause an error in your actual yield, right? Because now you have the burned remnants of a fly in your sample. So that's going to cause a problem. So what he did is he went around the building and caught 10 flies and ashed 10 flies and found the average mass of an ashed fly and subtracted that from the mass of his product. And so that helped a lot. Anyway, there's lots of different reasons that the actual yield can be different. The actual yield is not something we're going to calculate. You do the experiment, you weigh it, and that's your actual yield. We don't do experiments in this class. This is all lecture. So the actual yield will always be just given to you. They'll say the student got this much product, and they'll ask you what the percent yield is. Percent yield is a way of expressing how efficient we are in this reaction. And so here's the equation for percent yield. And it follows that same pattern of the part over the whole times 100. So this is important. It's the actual yield divided by the theoretical yield times 100%. So let's look at how we would use that. So here's a situation. A student dissolves, or dissolved. Maybe I'm missing a letter there. Dissolved. A student dissolved 1.00 grams of cadmium chloride in water. No, from the next verb, that's supposed to be dissolves. And adds sodium sulfide to obtain a precipitate of cadmium sulfide. The precipitate weighs 0.775 grams. Okay, this number, this is the amount of the precipitate. That is a yield. Yield is how much product. Is this a theoretical yield or an actual yield? Is it calculated, or was it found experimentally? It's found experimentally. It says the student gets this much precipitate. So that's the actual yield. And it can be tricky to decide what's the actual yield and what's the theoretical. The actual yield will always just be put out there for you, just be given to you. There's the chemical reaction. It says using stoichiometry, we calculate the theoretical yield to be 0.788 grams. Is that the actual yield or the theoretical yield? Theoretical yield. That's is that a trick question? It says the theoretical yield is, right? Theoretical yield. Calculated. Calculated to be 0.788 grams. What's the percent yield? Well, we're going to use that equation. Percent yield equals actual over theoretical times 100%. Now, if you're in a pinch on an exam and you can't remember the equation, you don't remember which one goes on top and which one goes on bottom, most of the time it'll work out if you put the smaller one on top. Because most of the time percent yields are less than 100%. So the actual yield goes on top, 0.775 grams. The theoretical yield goes on the bottom, 0.788 grams times 100. .775 divided by 0.788 times 100. 98.4. So that equals 98.4%. This is 100%. These units, grams, cancel out. And that's how things usually happen in a percent. You're comparing two measures of the same type of quantity. Numbers of people, meters, distances, well, a meter is a distance, masses, those sorts of things. Any questions? Let's do one more. Ammonium nitrate is used in explosives and is produced by the reaction of ammonia and nitric acid. The equation for the reaction is given here. If 15.0 kilograms of ammonia gives an actual yield of 65.3 kilograms of ammonium nitrate, what is the percent yield? The calculated yield is 70.5 kilograms. So we have three different numbers in this problem, and we need to make sure we pull out the correct ones, right? 15 kilograms of ammonia. Well, is that a product? Is ammonia one of the products? No. Ammonia is one of the reactants. So we've got 15.0 kilograms of that. And here they actually say actual yield of this. So that one's fairly straightforward. That's the actual yield. And it says the calculated yield. What's another word for calculated yield? Theoretical yield is 70.5. So this is the theoretical yield. I call him Theo, because theoretical is too long to write. That's the theoretical yield. Now, do we need this 15 kilograms? No, that's extra. Sometimes there's extra information in here. This whole couple sentences up here, do we need to know that? No, we don't. All we need to know is the actual yield is this, the theoretical yield is that. But there's this story involved, right? So percent yield, actual over theoretical. Theo times 100%. So we've got 65.3 kilograms divided by 70.5 kilograms times 100%. And then we should always look at our units. We don't usually do calculations with kilograms, we usually use grams. But in this case, we have kilograms over kilograms. They're going to cancel out, so there's no need to convert both of them to grams. You could, but it's just more work. And who wants more work? 65.3 divided by 70.5 times 100. Both of those numbers have 3 sig figs, so I'm going to round this to 3. It's 92.6%. Any questions? Now, these sorts of problems can be made a lot more difficult by giving you the masses of one or both of the reactants and making you calculate the theoretical yield. In both of these examples, the theoretical yield is given to you. But a more difficult version is making you calculate the theoretical yield using the stoichiometry process that we've learned about, and then find the percent yield. Any questions?